Okay, in this question, we've got several integrals to evaluate. Some of them are definite and some are indefinite. So actually half of them are definite and half are indefinite. So let's start with the first one, this integral. So you look at the integrand here, you notice that this is a power function. This is 3 times x to the power negative 4. Whenever you say power function, you need to write it as the x has to be up always, and it's okay, negative or positive power, or when it's zero power, like you have number 1. So it's convenient to think of it this way. So this is 3x to the minus 4. And the formula, if you remember the formula, the integral of power function x to the n dx is equal to x to the n plus 1 over n plus 1. So you add 1 to the power and divide by the new power plus c, but in this case you have a definite integral, so you don't need to put plus c. And also one small detail is that this is true for all n that are not negative 1. Negative 1 is the only power that this doesn't work with. Notice our question is not power negative 1. It's okay, it works with it. But for power negative 1, remember, so it's equal to this when the power is not negative 1, and then the integral of x to the power negative 1, which is 1 over x dx, it's ln x plus c. So it's the only one that doesn't follow the rule, the one that has power negative 1, and the integral is the logarithm, the natural logarithm. Good. It's a quick review, you know. So now we do this simple integral. So this is equal to 3x to the minus 4 plus 1 over minus 4 plus 1. So, and this you calculate between 1 and 4. They're telling us go between 1 and 4. Okay, good. So let me simplify things first. So this becomes 3x to the negative 3 over negative 3. There are things that cancel here. So the 3 cancels with the 3. And this becomes minus 1 over x cube from 1 to 4. Okay, and then you first put 4. So it's minus 1 over 4 cube minus, and now put the 1 in this formula for x. So when we did this, first you put the 4 in for x, evaluate it, then put minus, and then evaluate the other point in the formula. Minus 1 over 1 cube is 1. So this becomes minus 1 over, what is 4 cube? 4 times 4, 16 times 4, 64. Minus 1 is plus 1. So this is 1 minus 1 over 64, which is 64 over 64. You can think of the 1 minus 1 over 64, and of course 63 over 64. That was a nice answer. So let's check 63 over 64. Let's see here. We have the integral. This is the definite, so you have it also in your Casio calculator. You can always evaluate definite integrals. So try it now also in your calculator to see if you know how to use the calculator for it or not yet. If you don't know, then watch some of my other videos that teaches you how to do it. So let's see. This integral, so it's okay. Now we can say this integral, we got it. We got the answer to be 63 over 64. Let's check. Equal. Yes, perfect. So we know that this answer is correct, and so we can safely move to the next question. So the next question, oh, this one is even easier. Notice that all of them are powers. This is 4x to the power 1. Okay, so this integral, you apply the power rule. You see, it will be, it will be 5, and then x to the 4. When you integrate it, it's x to the 5 over 5 plus 3, and x squared, when you integrate it, it becomes x cubed over 3 minus 4, and then when x to the power 1 you integrate it, becomes x squared over 2 plus, when you integrate 1, you get x. because the derivative of x is 1. So the integral of 1 is x. Okay, plus c. Here you need to put plus c because it's a definite integral. And now simplify it. Of course, you see nice things happen here. 3 cancel the 3, 4 and 2, and you get 2. Yeah, you see? So it's considerably better looking now. X to the 5 plus x cubed minus 2x squared plus x plus c. I think this is the easiest question so far. So let's see on the calculator. We want the integral of, let me make it smaller so I can see things better, 5 x to the power 4 plus 3x squared minus 4x plus 1, and I like to put them in parentheses before I evaluate. It looks much better like this, equals. They took x as a common factor. Here, the calculator doesn't put c, and that's why if you don't have c, in these you can take x as a common factor, and it becomes x to the 4 plus x squared minus 2x plus 1, and you can put plus c like this. So it is the same as the calculator answer, and we're done with part B. So let's go now to part C. Whoa. Part C is an interesting one because it has an exponential here, you see, and it has a polynomial or a power function here. So you remember for exponential power, you do the killing game. So here, you remember whenever you have a power function times exponential, you do the kill game. And this is what I will show you now, how to do it. It's just you write the polynomial 1 plus 2x, and you start taking its derivatives. So what's the derivative of this? It's 2. And what's the derivative of 2 is 0. See, this is why we say you killed it, kind of. You killed the polynomial by taking derivatives. And you take integral for e to the 2x. So the first integral will be copy paste and divide by 2. Then copy paste and divide by 2, but you already have a half, so 1 over 4. Yeah, so now you put a plus on this arrow, and you put an arrow here with a minus. And if there was more stuff, you continue with arrows, but you stop at 0. So you know where to stop. Always you stop at the one before 0. And these arrows go down 1 down. So here these are on the same level, so you go from the first one on the left to the second one on the right. That is your first one, and then after that you can see how it goes. So this will be, so this is equal to, and now I'm reading from here. I'm going to multiply this by this with a plus sign. So it's 1 plus 2x times half e to the 2x minus, this is the minus that you see here. Now I multiply 2 by this. And when 2 multiplies 1 over 4, you get half. So minus half e to the 2x. Of course, we will put plus c because we know it's a definite integral here, an indefinite integral. Okay, so now maybe you can simplify things. Yeah, things cancel here. If you multiply 1 by this, you get half e to the 2x plus 2x times this plus x e to the 2x, because the 2 and the half cancel when you multiply them, minus half e to the 2x plus c. Look at the beauty of this. Half e to the x minus half e to the 2x. I mean, half e to the 2x cancels. And so the final answer is very simple. X e to the 2x plus c. Okay, so let's check that this is the right answer. I mean, you can check it with the calculator, or you can, of course, your calculator cannot do the indefinite integrals, the Casio calculator. So you can check it by hand. I'll show you in a second. Just let's see how our calculator will evaluate this. Something times e to the power 2x. And what is it? 1 plus 2x equals e to the 2x times x here. Correct? And also another way to check it if you don't have a calculator is this. So now this is the answer. Why don't you derive the answer and check if the derivative of the answer is what you have here? Because the integral of this gave us this, which means if I take the derivative of this, I am expecting to get, of course, what I had at the beginning here, what I integrated. So I expect to get 1 plus 2x e to the 2x. Okay, so let's see. When you take the derivative of x e to the 2x, you will apply the product rule, something times something plus something times something. So derivative of x is 1 times e to the 2x plus x times the derivative of e to the 2x is e to the 2x, and the 2 comes down. So this will be e to the 2x plus 2x e to the 2x. Take e to the 2x as a common factor. Inside you'll have 1 plus 2x. People usually write the polynomial before the exponential. So like this. And verified. So it is the same as what we were expecting. And so we're done, and it's correct. Good. This finishes part C. Now let's go to part D. In this part, it's just a definite integral, but you need to look at the integrand here, this, and write them in the appropriate way. And I'm sure you know what I mean by this. The appropriate way is the power. So radical x is x to what power? Half. Plus 1 over radical x is x to what power? Negative half. Dx. See, now you can apply the power rule. The power rule says add 1 to the power. So if it's half, it will be 3 over 2 over 3 over 2 plus add 1 to negative half, you get half. And no plus c here because it's a definite integral. This is from 1 to 9. But first we simplify how it looks, and then we evaluate it. This is 2 over 3 square root of x cube, or square root of x all cube, easier. Yeah, square root of x all cube plus radical 2 radical x. This whole thing equals 2 radical x. Make sure you see why, and you understand that it's a very simple thing to do. Okay, and this goes from 1 to 9. Now is the time to replace things. So because of this, I'll change colors. So I'll put 9 in green. Let's make it thicker. 9 in green and 1 in orange. So that you see that first you apply the green. I want you to make sure that you do it 3 times in this video, so you don't ever substitute 1 first, ever. Never do that. First you substitute the 9. Okay, so this is equal to 2 over 3 radical 9. You know, radical 9 is 3, we know already, and 3 cube is 27 plus 2 radical 9 is 3. So I put them here, and then you have minus, and now you substitute 1. So you put 1 first here, then here. Okay, so you have 2 over 3, 1 cube is 1, plus 2 radical 1 is 2, because radical 1 is 1. And now you just have to evaluate this. So let's keep this out of the way and see. Yeah, 3 cancels, and this is 9. 9 times 2 is 18, plus 2 times 3 is 6, minus, what is this? Okay, let's say minus 2 over 3, minus 2. 18 plus 6 is 24. 24 minus 2, 22. Minus 2/3 is 21 and 1/3, which is 68 over 3. I guess. So 68 over 3. Let's see. We can check it, of course, now. with the calculator, and this is one of the ones you can do with your calculator because it's a definite integral. So the integral from 1 to 9, and please do it with your calculator to check it also while you're solving this with me. Okay, radical x plus a fraction 1 over radical x equals 64 over 3. Why did I say, I'm sorry, I said 68, but it should be 64 over 3. You know how I did it? In my head, I was thinking of 22. How do I write it? I can write it as 66 over 3 minus 2 over 3. And I don't know why, for some reason, it escaped me, but it is, yeah, 64 over 3 is the right answer. Okay, and so what is it as a decimal? 21. This is 21.3333 forever. Okay, that's nice. So we solved this question, and now we will go to the next one. Okay, now we are in part E. This is an integral where we have power and logarithm. Power and logarithm has a rule. You see, power and logarithm has a rule here, and when a is not -1, so the power -1 is the bad power for log and for the power function. It's the one that has a special case, but any other power is fine. And in our case, the power that we have here is 2x squared, so it will be the general case. So if I have the integral of x squared ln of x dx, then you just do x to the 2 plus 1, x cubed over 3 into ln x minus 1 over 2 plus 1, 3 plus c. So if you can, of course, put the things inside, and you get 1 over 3 x cubed ln x minus 1 over 9 x cubed plus c. So I think that, why don't I just cut this and paste it here. In fact, you see, I put plus c, but this question is a definite integral, so nice. So this is from 1 to e, and so what I'll do is I'll remove the plus c here, and I will do it as between the two numbers. So in fact, it's even easier to do it with the simpler one, not to multiply everything out. So I will erase this one and say that here we will go from 1 to e. And so 1, I'll put it in red, and e, I'll put it in green, so that you see when I'm substituting. So first substitute e. So this is equal to, and now substitute e. It will be e cubed over 3 into ln e is 1 minus 1 over 3. Okay, so remember, when you put the e here, ln of e is 1. Don't forget this. Very important. It helps you always to simplify things if you notice it. Okay, if you don't notice it, you can still write it like that, but it will take longer to simplify afterwards. Now we'll do this minus, and we'll put the 1 now. The e, I just erased it by mistake. Okay, so now we'll put the 1 in this formula. Nice thing is, when you put ln of 1, remember, ln of 1 is 0. If you forget it, you can always recover it from your calculator. You see, ln of 1. In fact, any logarithm, this ln of 1 is 0, but in fact, any logarithm to any base, if you put base 2 of 1, is 0. Because any number to the power 0 is 1. Okay, so log base anything, 52 of 1 is 0. You see, any base of the log of 1 is 0. So minus, now put 1, it will be 1 cubed over 3 into ln 1 is 0 minus 1/3. Good. And now the green, I will try to simplify it. So this is equal to let's see how do we simplify the green. So it will be e cube over 3 minus 1 over 9 e cube. And now let's see what happens with the 1. Minus minus is plus. 1/3 times 1/3 is 1 over 9. So this is okay, yeah. So you can actually combine. By the way, there was something that I should have done. This here, 1 minus 1/3 is 2/3. It could have been much easier to do it this way. Let me just go back and say e cube over 3 times 2/3. It's just much easier. And now the answer here will be 2 over 9 e cube plus 1 over 9. So you can even write it like this: 2e cube plus 1, and with a common denominator 9. Okay, and we can also check how much is this numerically. Let's see first, we will check if this integral is correct. So the integral from 1 to e of x squared ln x equals 1 over 9 2x cube plus 1. Yeah, so you see 1 over 9, you can take it as a common factor, and inside you'll have 2e cube plus 1. And if you want to know what is it as a decimal, approximately 4.4746 if you want it to 4 digits after the decimal. 4.5746. Yeah, correct. So this finishes part E, and we have the last one now, part F. So let's see part F. Okay, part F also has a power function and a logarithm. Notice that you can write this as the integral of 1 over 3 x to the negative 1. It's important that you see what is the power of x that is multiplied by the log. Log of x squared. But notice, from log, this 2 that you see here, bring it down. You don't want to see it in the log. You want to simplify things. So bring it and put it here instead of the 1. Okay, so here. So take the 2/3 outside because they will make it easier if you don't see them. 2 over 3. Now the integral of what? Of x to the negative 1 ln of x dx. Notice this is the special case when power n is negative 1. This is the integral of x to the n ln x dx, where n is negative 1. So what do we know? If you have x to the negative 1 ln x, then the integral is half ln x squared plus c. So you will say this is equal to 2/3. Let's put it here. Yeah, this is equal to 2/3, and then the integral here is half of ln of x squared, and you'll put plus c outside, and now 2 cancels 2, and you get 1/3 ln of x, all of it squared, plus c. Notice this 2 is for the logarithm, so it cannot come down. What can come down is if you have it like this, ln x squared. This is, yes, it is 2 ln of x, but ln of x, all of it squared, is not 2 ln of x. So what is it? It is actually ln of x times itself is ln of x squared. And 2 ln x is ln of x plus itself. So you cannot say that the addition is the same as the multiplication. They are not the same. Good. So let's just check this last one to finish this question. Let's put it here. Okay, and so we want the integral of a fraction up you put ln x squared, close it, and down you put 3x equals ln of x squared over 12. So, you know, it is the same as our answer. This is our answer. And look at the calculator answer. Let's see why. The calculator says that it's ln of x squared over 12. Notice, this is equal to ln x squared. You can bring this 2 down. So it will be 2 ln x, all of it, squared over 12, which is 2 squared is 4 times ln x squared over 12. And now the 4 and the 12 cancel and you get 3, which will give you this. So just to let you know, it was the same, but the calculator put the x squared inside the ln. For me, I didn't want to put it inside. I simplified it from the beginning. So in fact, I would say that in this case, my answer is better than the calculator answer. Okay, so, and I mean, not better, they are the same, but mine is simpler because within the log, you have x only in my answer, whereas in the calculator answer, they have x squared. You can bring the 2 down, then it squares to 4 and cancels with 12 to give you the 3, if you want to get the 3. Okay, so this finishes this question, and I will stop here.